Welcome. In this quick tutorial, we'll build your first groundwater model using Anaqsim. We'll walk through a practical setup to simulate a pumping well in an unconfined aquifer. Don't worry, more complex models are coming in later videos, but for now, let's start with the basics. First, we'll sketch out our conceptual model so you can visualize what we're building. We're using the hseg boundary generator, the fastest and easiest way to create model boundaries in Anaqsim. If you'd like to dive deeper into hseg, check out our short video on it. We'll create a circular domain, and I'll just note that hseg boundaries are always circular, where we can define the groundwater flow direction and gradient. To keep things clear and manageable, we'll use a single layer to represent an unconfined aquifer. Then, we'll add a well and simulate its pumping effects. That's it, a straightforward example to get us started. Let's jump in. Let's get started by opening Anaqsim and creating a new model. Go to Model Input and select General. Here, we'll set our units and add any notes for future reference. Check the steady state box to indicate this isn't a time-dependent simulation. For units, we'll use meters for length and days for time. One important note, Anaqsim doesn't actually recognize the units you choose, it just runs calculations based on the values you enter. That means you have to keep your units consistent. If you're using meters and days, all your inputs, like hydraulic conductivity and domain thickness, must also be in meters and days. Most of the time, meters or feet for length and days for time work best, but whichever you choose, consistency is key. Finally, let's name our file Tutorial1 and save it by going to File and clicking Save. Our next step is to define our model domain, or in plain terms, describe our aquifer for the simulation. Every model needs at least one domain. First, click Model Input and select Domains from the drop-down menu. You'll see three options. For this example, choose Confined and/or Unconfined to let Anaqsim know we're working with an unconfined aquifer. We'll explore the other options in future videos. Once selected, an input table appears. Here, we'll describe the aquifer properties. In the Label Unique field, type a simple description like aquifer. That's all we need for now. Under Level, select 1. Next, choose Unconfined as the domain type. Set the top elevation to 50 meters. While this isn't the ground surface in Anaqsim, we'll assume it is for this tutorial. Set the bottom elevation to 35 meters to represent the base of our aquifer. For average head, enter 47 meters, slightly below the top elevation. This gives us an average saturated thickness of 12 meters. We'll stick with the default values for porosity, storativity, and specific yield. For hydraulic conductivity, or K values, enter 24 meters per day for K1, K2, and K3 to create a homogeneous model. Lastly, we'll skip the angle K1 to x-axis field for now, but just know this option lets you set preferential flow directions when needed. Now, go to File and click Save to save your domain input. And that's it. We've defined our aquifer and are ready for the next steps. Feel free to pause the video if you need more time to fill in all the input values. Next, we'll define the model boundary. This is the horizontal extent of your simulated aquifer. This is where we use the hseg boundary generator, which lets you quickly set up the groundwater flow direction and gradient for your simulation. Go to Model Input, choose Line Boundaries from the drop-down menu, and then select Head Specified External with Gradient from the next drop-down menu. An input table will appear. First, select Domain, and you'll see a drop-down menu with all the domains you've created. Since this model has only one domain, you'll have just one option here. Next, set the center of the domain using an XY coordinate. For this example, use 0, 0. In later videos, I'll show you how to shift your entire model to a new location with a single coordinate change. Now, fill in the radius, gradient, and gradient direction fields. Set the radius to 2,000 meters. Set the gradient to 0.0001. That's a 1 meter drop in groundwater level over 10,000 meters. Finally, set the gradient direction to 135 degrees in polar coordinates, which points to the northwest. Click Parameters per line and select 3 from the drop-down menu. We'll cover line parameters in more detail in future videos, But for now, just know that this value controls how many calculation points are placed along each of the 12 line segments in your HSEG boundary. A higher number gives you better resolution, but increases the number of calculations Anaqsim needs to run. Now, go to File and click Save to save your input. We've now created a basic groundwater flow model, so let's take a look at the results so far. Start by clicking Solve in the top menu bar. Anaqsim will automatically switch to its log view, where you can see how the calculations are progressing. Since we're running a simple model, it will converge almost instantly. Next, go to Make Plot in the top menu bar and choose All Selected Features, Same Level Time. Right now, you'll only see the HSEG boundary. So, let's turn on the groundwater contour view. Go to Plot Input in the top menu bar, select What to Plot from the drop-down menu, and check the Contours box. Then, click File and Save. Now, click Make Plot again and choose All Selected Features, Same Level Time. This time, you'll see the simulated groundwater flowing in the northwest direction, just as we specified. Now that we've simulated a basic groundwater flow field, let's add a well in the center of the model. Go to Model Input and select Pumping Wells from the drop-down menu. You'll see three options. Choose Discharge Specified. An input table will appear. Under Label, give your well a unique name, like W1. Next, choose the domain where you want to place the well. Since we only created one domain for this example, you'll have just one option. For the XY coordinates, enter 0, 0 to place the well right in the center of the aquifer domain. Now set the radius. The default is 1, meaning a 1 meter radius, since we set our length units to meters. That's a bit large for a well, but we'll leave it as is for this example. Finally, enter the discharge. This is the pumping rate we want to simulate. Enter -100 to represent 100 cubic meters per day. The negative sign tells Anaqsim this is a pumping well. If you enter a positive value, Anaqsim treats it as injecting water into the well, useful for projects like aquifer storage and recovery. Once that's done, go to File and click Save to save your input. Now, let's visualize the results again. Since we added a new element to the model, we need to click Solve in the top menu bar once more. Once the solution is complete, go to Make Plot and select All Selected Features, Same Level Time. This time, you'll see the effects of the pumping well on the groundwater flow field. Since Anaqsim doesn't rely on a mesh or grid, you can zoom in on any part of your model to get a high-resolution view of the results. Let's try it. Hover your cursor over the well and zoom in using your mouse wheel. Next, go to the top menu bar, click Plot Input, and select Set Plot Window to Current View from the drop-down menu. Then, go to Make Plot again and choose All Selected Features. Same Level Time. Anaqsim will replot the model with higher resolution around the well. If you want to zoom back out, just scroll your mouse wheel out and repeat the same steps. And that's it. In just a few minutes, we built a functional groundwater model. Now it's your turn to experiment with your model. Remember, because Anaqsim doesn't use a mesh, you can tweak almost anything in your simulation with just a few clicks. Go ahead, try it out. Change the radius of the model, adjust the aquifer thickness, modify aquifer properties, move the well, or even add more wells. Just one important note, don't change the name of your aquifer domain. That will break the references in your model. Thanks for watching. See you in the next one.